So the first question says a sociologist reviews randomly selected surveillance videos from a public park over a period of several years and records the amount of time people spent on a smartphone. The statistical procedure the sociologist used is called what? Well, I know it's not going to be an experiment. An experiment would be where you have two groups of randomly selected people. One gets treatment such as a medicine or something, and the other gets no treatment like the placebo. So it's not an experiment. This is an example of an observational study. The observer just watched. It was a hands-off approach. They watched, they did not interfere. A census is when a sociologist, for instance, a researcher, would ask the entire population, and a sample survey is when you would ask just part of a population. In this case, nobody was asked anything, so it was a sample survey. Number 2, so now let's get into some of the algebra part. Which statement is true for all real numbers? We're going to have to multiply them out and see which one works. Now, you don't have to multiply all of it out just until you find the error. So I'm going to take choice 1 and I'm going to multiply out x minus y times x minus y, because we know that that doesn't work where you just square each term. So we're going to have to double distribute, and we'll get x squared. This is minus xy plus y squared, and that is negative 2xy in the middle, and choice 1 doesn't work. So you can cross off choice 1 and you can cross off choice 3. Now we got to see if number 2 works. For number 2, we're going to write this out 3 times. And double distribute. So I'll double distribute the second chunk first. So in that case, I'll have x squared. This is positive xy plus xy is plus 2xy. And we'll have plus y squared. Now when we distribute this x into that long trinomial, we'll have x to the third plus 2x squared y plus xy squared. I'll distribute that y now, and we'll have plus x squared y. I'm putting each of the terms in standard form so they're easy to find like terms. And then I'll just combine my like terms, put it in simplest standard form. So the x cubed will go first, and I have 2x squared plus 1x squared is 3x squared y. And already we can see that that 2 is not working either. We'll continue to do the next part. 1 and 2 make 3xy squared, and then we have plus y to the third at the end. The middle guys here are not like terms because they are not exact matchers with the variable and exponent combination. So in this case, the answer was choice 4. Number 3. What's the following system? What is the solution set of the system of equations? The solution set to a system, because we have x and y, we're looking for both answers. So you can do this algebraically or graphically. Let's do it algebraically first. Since they're both equal to y, then I can say that they're both equal to each other. So I can set 3x plus 6 equal to x plus 4 squared minus 10. This is going to be the longer way to solve it. Again, we're going to have to write this out twice and double distribute. So that'll be x squared plus 4x plus 4x is plus 8x. So I'm going to continue to solve here. Now that I have everything multiplied out, I'm going to get it equal to 0. So I'll move those two terms over to the other side. X squared plus 5x, those 6's are going to cancel out. I'm just going to put my 0 on the right-hand side. Now this is GCF factoring, so my greatest common factor is x. I'll have x plus 5 equals 0. So I have two answers, values of x anyways. So these are just my x values. Now I have to find the matching y values. What you can see is that in choice 2, it can't be choice 2 because that doesn't have either of these numbers. Now we're going to find the y values that go along with it. You can plug it into either of the equations. I think that first, the linear equation is easier, so I'm going to find the y value by just plugging in that x. So that's going to be 6. Then if I plug in my other x value, that's going to be -9. And what that gave me is my solution set are, make sure you match up x equals 0, went with y equals 6. And my other point, x equals -5, went with -9. A solution set should be put in curly brackets. That's the algebraic method. Now that took a long time. On your final exam, you might want to go to your y equals screen and type that in. 1 into y1. I know this is going to be a parabola because it's in vertex form. And I can see that the vertex of that parabola is going to be -4, -10. I'm going to go zoom 6 to get the standard viewing rectangle, and there we go. So graphically, what you can do is draw the picture. I'll just draw it, I guess. I'm going to draw this, and I'll draw my parabola, look like this. My line was approximately like that. So if I want to come up with those 2 points, I'm hoping that they match my algebraic system. But if I were to start to do it graphically, let's see what those points are. In order to get the intersection point, you're going to press second, trace, and then choice 5 is the intersect menu. So second, trace, press 5, and you can see on my screen it says left bound. I don't know where I am, so at the bottom of the screen you can see that moving. So right now my x is at -10. I'm going to say, I think it's at like, what did I say, -5. So I'm going to guess left of -5 is -7. And I could just hit enter. And then, left bound. There we go. And then right bound, I'll say it's -1. Hit enter. Intersection, I'm just going to hit enter again. And it tells me my intersection point here is -5, -9, which I got algebraically. You can do that same process for the intersection point. The upper one, which it would be right there, it looks like it's at 0. So if I say left bound would be, I don't know, -3. And right bound, I'm going to type in +3. And it gave me my intersection point of 0, 6. So each way I did that, I saw my correct answer was choice 3. Now moving on to number 4, we have a graph. Irma initially ran 1 mile over 10 minutes. She then began a training program to reduce her 1 mile time. She recorded her 1 mile time once a week for 12 consecutive weeks, as modeled in the graph below. All right, so before I get answering these, talking about increasing or decreasing, although this is a decreasing function, we got to think about what the numbers mean. So the x value and the y value, if I just pick points, is 5, 6, 7, 8, 9, 10. So that's at week 0 was 10. Initially, it was 10. If I look at week 2, that was 5, 6, 7, 8. At week 2, she's running an 8-minute mile. So her time is going down, which means as your time decreases for your mile, that means you're getting faster. So which statement regarding Irma's 1 mile training program is correct? So 3 of them are going to be false. Her 1 mile speed increased. Her speed increased as the number of weeks decreased. Well, if your time is dropping, that means that your rate of change, your speed, is increasing. So you're going from, this would be 6 miles per hour, and this would be 7.5 miles per hour. So her 1 mile speed increase, this seems like it's true. This is the right answer, but let's look at the other ones because a good test taker does all of the questions, all of the choices. Her 1 mile speed decreased as the number of weeks increased. Well, you can see why this is an answer choice because it looks like it's going down. So if you're not reading carefully, you might accidentally choose that one. But her 1 mile speed is not decreasing. Her time is decreasing. So her speed isn't, but her time is. So that's false. If the trend continues, she'll run under a 6-minute mile by week 13. 5, 6, 7, 8, 9, 10, 11, 12, 13. So will she run a 6-minute mile by week 13? I would say that that's false because then we could say she'd run a 4-minute mile in 20 weeks, but also because the trend of this, it seems to be leveling off. So this is going to be false because it's not really decreasing as quickly. There's smaller gains in speed in that case. And she reduced her 1 mile time the most between weeks 10 and 12. So where was her most dramatic time difference? It's not, they said between weeks 10 and 12. That only went down a little bit. They're talking about average rate of change in this case, whereas her biggest time decrease was in those first couple of weeks. So the answer to that is choice 1. Let's look at the 7-year lease. A 7-year lease for office space states that the annual rent, so that means the yearly rent, is $85,000 for the first year, and then it increases 6% each additional year of the lease. What will the total rent expense be for the entire 7-year lease? So the total rent expense for the 7-year lease. Well, let's ballpark it. So if it's $85,000 per year and they're renting it out for 7 years, when you type that into your calculator, that's $595,000. But the answer is not choice 3. That's a shiny wrong answer. My math here didn't account for the 6% increase each additional year. The percent increase formula is a formula that you should know. Percent increase. So it's a percent increase. We're going to have 85,000, 1 plus 0.06. Now, if we put in, 1 here, that's not going to add up. That's going to be how much it is after the first year. And then if we do 2, that's how much it is after the second year. What we have to do is find the total rent expense for the entire 7 years. So what we have to do is we have to add up all of the years in order to get this. Now, if we tried to type in this 85,000 times 1.06 and raise that to the, let's say, the 7th, we'll get that number. That's not even an answer choice. That's just how much it's going to be in the 7th year. So let's add up the first year, second year, third year, up until the 7th year. We don't want to do this. It's going to take us too long to add them all up. So what we're going to do is we're going to use the formula. We're going to use the formula for geometric series, the S sub n. This is going to be a geometric series. I know it's geometric because the pattern is we're multiplying. What we multiply each year is that increase. When you have this equation here, this is your multiplier. So the 1 plus 0.06 is going to be 1.06 as my common ratio. I'm going to plug that into the formula that you're given on your reference sheet. Make sure you're using it. So my first one is 85,000. A sub 1 is 85,000. 1.06 to the 7th. 1 minus 7. Now when you type this into your calculator, you have to be careful that you type it in right. I start with parentheses times 1.06 to the 7th. So make, I'm going to delete these extra parentheses. What do I do here? There we go. Then I'm going to hit divided by, open up parentheses again, and it's, what I did here, 1 minus 0.06. 1 minus 1.06. So parentheses are on the top, hit enter, and then parentheses are on the bottom. Not working out for me today. 1 minus 1.06. Hit enter, and we get this number. So this is 713,000, which is, you know, closer to 595, but it's obviously above it because they're charging 6% more each year. That's my final answer, is choice 4. For number 6, we have a graph and we just have to say which expression defines f of x. A few ways that you can do this question, they all involve your calculator. You should know that the shape here is an exponential graph. This has an exponential shape, so you're going to cross off any equation that is not exponential. Choice 1 is linear, so we'll cross that off. Now what's nice is they give us points. We're just going to type in each of these equations and come up with which points match. Let's go back to your y equals screen. Let's type in choice 2. Go to your table of points and see. Let's see. Why am I? Oh, there we go. Okay. So I'm looking for 210. My graph here says that I have 220. So that's automatically not it. Let's go back to your y equals and type in the second one. Now when you type in this exponent, and the same thing with choice 4, if you have a TI-83 calculator, you're going to do 5 parentheses 2 caret, and you're going to have to put that that exponent in its own set of parentheses, or it's not going to do it right. Same thing with choice 4. You're going to do 2 caret, and you have to put that 2x in its own set of parentheses, or else you're not going to get the right answer. Make sure you know how your calculator works. So I'm going to have my calculator up here. This is the 84. So it makes the exponent already for you. You don't need extra parentheses. Now when I'm looking at my table of points here for choice 3, I have 210, that's good. I have 4 and 20, and I have 6 and 40. So this is the answer. A good test taker doesn't bail. We're just going to make sure. So again, I'm going to have 2 caret 2x. Make sure you're getting the same table of points. Okay, so for choice 4, let me see, I have 120, I have 280. That's not even close, so it's not choice 4. Now there's an alternative way of doing this too. You can use the exponential regression function on your calculator in order to come up with the equation. So press Stat, Edit, Stat Choice 1. And you're going to put in this table of values where you have 210, 420, 420, and 640. So I'm going to type that in 2, 4, 6, and go over. Okay, so then I'm going to go back to Stat, over to Calculate. So then I'm going to go back to Stat, over to the Calculate menu, and I'm going to choose choice 0, which is exponential regression. Let's see what this calculator comes up with. Remember, you want your frequency list to be empty. And this came up with the values here. So we have y equals a times b to the x. My a is 5, which is correct because it was 5 and all of here. But my b is 1.4142. It's not going to show me this with the exponent. Now let's go back to fractional equations and make it look like what it's supposed to. So here's what the equation is supposed to look like. If I were to write down my answers here, it would be 5 times 1.414213 to the x. The difference is that here I have just an x, and here I have an x over 2. So what I can do is, if I take that 2 and I pull the x out of it using my properties of exponents, when you have a power to a power, you multiply those exponents. So I can just pull them apart. Now, 2 to the 1/2, 2 to the 1/2, and again, if you have an 83 calculator, you need those parentheses, that equals my 1.4142, and so on. So it is equal to each other. Two ways of doing the same problem. Let's move on to choice 7, or number 7. Which statement is true? This is screaming the remainder theorem. The remainder theorem says that if the remainder is 0, then it was a factor. Okay, so let's see what's true. Now it tells us this is a factor, this is a factor. Okay, so we have to decide which one is a factor. Let's start there. So let's ask ourselves, is x minus 1 a factor? How we determine that is either you can divide that p of x using long division, or you can use the remainder theorem, which says that if you're determining if x minus 1 is a factor, you're going to plug in 1 into your p of x and see what that equals. So just type that into your calculator. That's going to equal 0. Since x minus the remainder when I divided p of x by x minus 1, since the remainder was 0, that's telling me that this is a factor. Now, why isn't my answer choice 1? Well, because the choice 1 says it's a factor because p of negative 1 equals 2. That doesn't even make sense. In order to be a factor, the remainder has to be a 0, so that means choice 2 doesn't make sense either. What I just calculated over here was choice 4. It's a factor because p of 1 equals 0. Well, look at choice 3. Is x plus 1 a factor? Okay, so let's plug in. What you do is you plug in the opposite sign here. Now use parentheses. See, I have parentheses around there. You need them. So p of negative 1, when you type that into your calculator, p of negative 1 equals 2, not 0. So although p of 1 equals 0, that doesn't tell us that x plus 1 is a factor. That doesn't relate. So the answer is choice 4. Number 8. For x is greater than or equal to 0, because if x were less than 0, then you would have a imaginary number. Which equation is false? 3 of them are equivalent. They all equal this thing over here. One of them doesn't. And you can see there's a slight change here in this choice number 4. So we're just going to use the rules of exponents. Looking at choice 1 here, when you have a power to a power, multiply exponents, and please use your calculator to multiply those exponents. So that is going to be x cubed. So does x to the third power equal this? No, that's false. All right, what about this other one? Now we are going to again multiply exponents. So this equals x to the 4 thirds. Well, this is 4x3, and I know that the denominator, top in, bottom out, TBO. So the top goes inside, the bottom goes outside. Oh, how about I write that the right way? 3 times 4 is 3/4. So top goes inside, like I have here, and the bottom goes outside, like I have there. So in order to convert this, bottom outside, top inside, and that does equal the other side. So this is true. Let's make sure that choice 3 is true, because we already found the false one. Just making sure that they all work. Okay, so multiply this. When you multiply 3 halves, 3 divided by 2 times 1 divided by 2. Math, enter, enter. That's 3/4. And we already said x to the 3/4. And we already said x to the 3/4 was going to equal this. So that is true. Again, we're going to do this. Now we have x to the 4 thirds. And if we do top in, bottom out, top is going to be inside, so x to the 4th. Bottom is going to go outside, which is that cube root. So this one is also true, and that's why the answer to this problem was choice 1. Let's go on to number 9. Oh, the inverse. The inverse. When you see a word that you know you should know, it's sometimes helpful to write out quick notes. Switch x and y, solve for y. Let's not look at the answers first. Let's actually do the work first. Okay, so I'm going to switch x and y. And now I have to solve for y. So I just have to get y by itself. Subtract that 5. And then we're just going to divide each piece by 4. And so we'll have y equals either x over 4. They wrote 1/4 x. And that's why it is choice 2. Which is a geometric sequence. So a geometric sequence, remember the pattern is multiplying. Okay, so a cell phone company charges $30 per month for 2 gigabytes of data, and this for each additional gigabyte. So what they're doing here is they're adding on $12.50. That is not geometric, that'll be arithmetic. Temperature in your car is 75. You lower the temperature of your air conditioning by 2 degrees every 3 minutes in order to find a comfortable temperature. Here, you're subtracting 3. That's also arithmetic. You're adding a negative. David's parents have a set limit of 50 minutes per week that he may play online video games during the school year. However, they will increase his time by 5% per week for the next 10 weeks. This is my geometric one. What I'm multiplying by, you're not multiplying. Your multiplier is not 0.05. Your multiplier is 1 plus 0.05. So your common ratio is 1.05. And just to make sure, let's look at the last one. Sarah has $100 in her piggy bank. She even spelled her name right. And saves an additional $15 each week or per week. So here she's adding on 15. So the answer to that one was choice 3. Okay, 11. 11's a doozy. Let me show you how to do it algebraically, and then we're going to use the graph of it to help us solve for the factors instead. So we have to factor completely. Now, you're going to start factoring, and then you're going to realize, wait a minute, I have 2n squared terms. So if you take those n squared terms and add them together, and while you're doing that, you might decide, oh wait, I should probably put that in standard form. We'll come up with this. Now, trying to factor this, it's not helpful. So you would try to group these together and you would come up with this, but then you have a trinomial left over, so that doesn't work. So what else can you try? So then get this. So what you're going to have to do is rearrange the terms so they're in a better order that you can factor them. And what I'm thinking about is if I take n to the 4th minus 36n, I'm going to put those next to each other, and then I'm going to put I'm going to put the 4n to the 3rd first. I'm going to put this 4n to the 3rd first. And it was a minus 36n. Then I'm going to write the rest of it. But I'm going to make sure to put it in the right order. So n to the 4th minus 21n squared plus 108. Okay, so now I can factor by grouping here. I'm going to do the blue guys and then the green guys. Factoring the blue, my GCF is 4n, so I'll pull that out and have n squared minus 9. So what makes that nice is if you're looking at the answers, we're going to have 4 factors here probably. So let's see what happens with this. Now, if I take my green, I'm going to do one step at a time. Let me take my green guys. And this is actually just an easy trinomial. Like we did the other day in the previous example, we can just think about this as being like x squared minus 21x plus 108. What multiplies to 108 and adds up to 21? So you can type y equals 108 in your calculator into the y equals screen. 108 divided by x, and look at that table of points. And what you'll notice is that 9 and 12 add up to negative 21. So this could be negative 9 and negative 12. Relating it back to n to the fourth instead of n squared, we're going to have n squared minus 9 and n squared minus 12 because we had to break up that n to the fourth. Now, if you're looking at this whole chunk of stuff together, what you can see is that there's a greatest common factor here. So if we factor that out, and to factor, you divide it out. Let's factor out that n squared minus 9. So we're going to have n squared minus 9. And what's left over from the blue is 4n. And what's left over from the green is n squared minus 12. Well, let's keep going. N squared minus 9. N squared plus 4n minus 12. So now we're on our way. This is adopts, and this is an easy trinomial. It multiplies to negative 12, adds up to 4, positive 6, and what, negative 2? Okay, so now I'm finally ready to look at my answers, and I see that it's choice 2. This was very difficult to rearrange the terms and then get all that factoring right. So what we can do is we can use the relationship between factors and roots. Based on this, since this is a quartic function, I know I can have up to 4 roots. And if I have 4 roots, that means I'm going to have 4 factors. So go to your calculator, and you can see how you can use your calculator to help you factor something if you're stuck on factoring. So what I'm going to do is type into my calculator, I'm going to type in this just because it's in standard form. So my y equals x to the fourth plus 4x to the third. Okay, now I know my graph isn't going to fit in the standard viewing rectangle. Why is that happening? There it is. Okay, so I'm not fitting my whole graph in the standard viewing rectangle, so I'm going to try to zoom it out so I can see what's going on. What we said in class was when you're trying to graph something, look at the biggest number in the problem and let's just change that y value to that number. So we're going to keep the x values for now, but I'm going to change my y value to 108. Or maybe you want to make it 120, whatever. Let's make it 110. Now that's a better graph, and I can see from my equation or from my answer here that I know it says there's going to be 1, 2, 3, 4 answers, and I see that my graph crosses 4 times, which is good. So I'm just going to adjust my window so I have a really good picture. So again, that wasn't big enough. So remember what we said, we're going to approximately double it. And now it's tall enough, but I need to change my y min. Now my y max is at 200, so maybe I want to make my y min negative 100. Not good enough, I'll make it negative 200 also. There we go. So if you draw that, you can see how graphing it can help you find your factors. Let me go to my window again. X scale. On your graphs, you can see trace. You can see there we go. The points, the scale on your x-axis better. You have little numbers, and so you can't really see that on here, but this is at 3. That's at -6. This is at +3. I'm sorry, this is at +2, and the other one's at +3 because it's pretty close together there. We'll just erase one little small thing here. There we go. And then this is at +3. And that's what your calculator should say. Now, if you want to find the zeros, because what we just wrote down were the zeros of the function, you can go to second trace. Choice 2 is the 0. So I know that my 1 0 is at -6. So if I want to go to the left of -6, maybe I'll press -7. Right bound of -6 is -5. And it'll tell me that your 0 is -6. So I can repeat that process and find all the zeros if I want to. But the relationship is that the zeros and the factors, remember, have opposite signs. Is the shortest way of explaining that. So if I know one of my zeros is -6, then I know that that factor that's related to it that would get that 0 is x plus 6. And if my 0 is -3, then my factor is x plus 3. If my 0 is 2, my factor is x minus 2, and same thing with this. So I think graphing it in this case was much easier than doing all of that factoring, all of the algebra. All right, one more question on this section of the video. What is the solution when the equation w x squared plus w equals 0 is solved for x? Okay, so we have to solve that for x, where w is a positive integer. Okay, so let's solve it for x. Now, w has to be some positive integer. There's a couple of ways we can do this question. Let's solve it for x because it's not difficult to do that. Remember, we're getting x by itself. Few ways. Since it's quadratic, meaning you have an x squared, you can factor it to solve. The kind of factoring we would use would be GCF. So if I factor the w, I'll have x squared plus 1 equals 0. Okay, so I'm factoring out the w, and since I'm solving it, if I divide both sides by by w, I'll just have x plus x squared plus 1 equals 0 because 0 divided by w is just 0. Now solving this, I can subtract 1 because it doesn't factor. Now when I square root the square root of -1, that doesn't just equal I. Since I'm solving an equation that's plus or minus I. Which is your answer? Now there's other ways to do this problem. Let's say you couldn't think of that on your own. You can plug in the values that they give you and see which one actually works. Now they're saying, what is the solution when the equation is solved for x? That means that these numbers are going in for x. That's what x is going to equal. When will it always equal 0? Let's plug in x equals -1 into the equation and see what happens. All right, so let me plug in x equals -1. So w is some positive integer, -1 squared plus w. Does that equal 0? That's a question. Well, -1 squared is just +1, so this is just like 1w plus w. W plus w is 2w, not 0. And since 2 is some positive integer, pick any positive integer, that doesn't work. That doesn't equal 0. Well, let's try to plug in 0 for choice 2. All right, so if we have w times 0 squared plus W, does that equal 0? Well, 0 times anything is 0. Is 0 plus W equal to 0? No, that also doesn't work. Now, plugging in 6, you'll see something similar. Plugging in choice 6. Where do I want to do this? I'll do it up here. Plugging in choice 6. So again, for x, we're going to have 6 squared plus W. Does that equal 0? That is going to be 36W plus W. That's 37W. That does not equal 0. Because remember, W is some positive integer. So I actually works. Let me show you why. Let's just plug in positive I. We have W times I squared plus W. That's supposed to equal 0. Well, we know from the complex numbers unit that I squared actually equals -1. And that's negative W plus W. That does equal 0. And you'll see the same thing happen with negative I. All right, that's it for this section. Look for video 2 for 13 through 24 on the multiple choice.